Hi there, and welcome to this lesson on Pure Mathematics 1. In this lesson, we'll be looking at how you sketch cubic curves. And a cubic is something of the form y equals ax cubed plus bx squared plus cx plus d. And just as we learned how to sketch quadratic curves, we need to do the same thing with cubics. Quadratics all have the same general shape, and that's basically true for cubics as well. There are a couple of possibilities for a cubic. The most likely thing you'll get is something like that. So if a is positive, the coefficient of x cubed, if that's a plus number, then that will probably be the shape of it. If a is negative, then a bit like with quadratics, if a is negative, then it flips it the other way up. And you'll get something like that if a is a negative number. Sometimes this maximum and this minimum, they get closer and closer and closer to each other until they join, and you get what's called a point of inflection. So a cubic curve can look like that in special circumstances. And again, if a is negative, same general shape, but it'll be that upside down. In terms of how the curve meets the axes, that's probably the most likely thing you'll meet, where the curve comes up above the axis, goes back down beneath it again, and then goes up again. And you'll notice that there are 3 crossing points on the x-axis. 1 crossing point on the y-axis, but 3 on the x-axis. But it's possible for the curve to shift upwards, in which case this minimum point is above the x-axis, and it only actually crosses the x-axis on the one occasion. And the other possibility is the whole thing shifts downwards, and this maximum is beneath the x-axis. In which case, again, the curve only crosses the x-axis once. You'll notice it always crosses the x-axis at least once, and it always crosses the y-axis exactly once. Okay, we'll do an example. Sketch y equals x plus 4 times x minus 1 times x minus 3, showing the crossing points on the axes. And you'll notice, as when we were doing quadratics, they're asking for a sketch. That means they don't want you to use graph paper. They don't want you to do an accurate scale. They just want you to do a sketch which shows the general shape of the curve and where the curve crosses the x-axis, where it crosses the y-axis. Very similar to doing quadratics. So I'll let you have a go at this one yourself first. When you're ready, come back to me, but pause the video first. Okay, let's have a look at this together. Now, when we sketch quadratics, we'd find the crossing points on the axes, and the easiest one to find is the crossing point on the y-axis, which is when x equals 0. Now, if x equals 0, in these brackets, you'll just have 4 times minus 1 times minus 3, and that gives you plus 12 for y. So that's the crossing point on the y-axis. It crosses at y equals 12. To find the crossing point on the x-axis, you say what happens if y equals 0. Now, if y equals 0, then there are 3 possibilities. Because this has been factorized, you can go straight to the answer. If the first bracket is 0, that means x is minus 4. If the second bracket is 0, x is 1. And if the third bracket is 0, then x is 3. So 3 crossing points on the x-axis, and 1 crossing point on the y-axis. Minus 4 would be about there, 1 would be about there, 3 would be about there, and I put 12 there on the y-axis. It's a right way up quadratic. If we multiplied all of that out, we'd have plus 1x cubed. So we know the general shape is going to start bottom left, it's going to head up towards a maximum, go back beneath the axes, and then head up towards plus infinity. So something like that will be the general shape. Okay, example 2. Have a go at this one. There's a very important difference in this question. You'll notice we've got x plus 4 and x minus 1. This bracket's been flipped around and we have 3 minus x. That means if we multiplied these brackets together, we get x times minus x. We'll have minus x cubed. So it'll be an upside down cubic curve. But you still use exactly the same method to do the sketch. So I'll let you have a go yourself first. Pause the video, come back to me when you're ready. Okay, again, we'll find the crossing point on the y-axis first. What happens if x is 0? If x is 0, we'll get 4 times minus 1 times plus 3 this time. So now we'll get minus 12. What happens if y equals 0? Well, if y equals 0, we actually get exactly the same as we got on the first example. We'll get minus 4 plus 1 and plus 3. So same 3 crossing points on the x-axis, but the y-axis one has changed from plus 12 to minus 12. So the crossing points would be something like that. And as we said, it's an upside down cubic, this one. If you multiply out the brackets, you'll get minus x cubed. So it's going to start up at plus infinity, come down to minus 4, go underneath the x-axis, back up again, and then head down towards minus infinity. So it'll look something like that. Example 3. Now what's different about this one is we have a repeated root, x minus 1 squared. So it's x plus 4 times x minus 1 times x minus 1 again. And the question is, what does that mean? What's the significance of that x minus 1 squared when we sketch the graph? Now I'll let you have a go at working it out yourself first. So pause the video, have a go at this, use exactly the same method, and then come back to me when you're ready. Okay, as I said, we use the same method. So we start off by saying, well, what happens if x equals 0? If x is 0, we'll get 4 times by minus 1 times by minus 1 again. And that gives us 4. So the crossing point on the y-axis will be plus 4. What happens if y equals 0? Well, if y equals 0, there's 2 possible solutions. If this bracket is 0, we'll get minus 4 for x. And if this bracket is 0, we'll get 1 for x. Although strictly speaking, we get that 1 twice. That's it for the crossing points. So we've just got 1 point here at minus 4, 1 point here at 1, and 1 point here at 4. It's a right way up cubic. If we multiplied out the brackets, we would get plus x cubed. So it is going to start down here at minus infinity. And it looks like it's going to cross through the axes there. It's going to come down here. And now it's got to finish up there at plus infinity. The significance of this repeated root, x minus 1 squared, is that the curve is going to come down to 1 and it won't cross the axis there. It'll just touch the axis of 1 and then head up. So you'll get something that looks like that. X plus 4 is a crossing point, but the repeated root is not a crossing point, it's a touching point. That's the significance of getting a repeated factor, and you always get that. So if there's a repeated factor, it'll be a touching point on the x-axis. Okay, example 4 gives you a little bit of work to do before you can get started. Up until now, they've been factorized for you, but this question has not been factorized. So the first thing you'll need to do is factorize that into 3 separate terms. I'll let you have a go yourself first. Pause the video and then come back to me again when you're ready. Okay, let's have a look. So we said you're going to have to factorize this. All 3 terms have x in. So the first thing you would do is take, before I factorize it, start off in the same way as before. Say what happens if x equals 0? Well, if x is 0, all these 3 terms are 0, so y is equal to 0. Then we say what happens if y equals 0? Well, if y equals 0, this whole expression is equal to 0, and this is when you need to factorize it. So I can take x out, and that'll give me x into x squared minus 2x minus 3 equals 0. And then this quadratic in the brackets here, that does factorize as well into 2 brackets. Gives us x times by x minus 3 times by x plus 1 equals 0. Now it looks like the other questions, and you can treat it in the same way. So if y equals 0, there'll be 3 crossing points on the x-axis, one where x is 0, one where x is 3, and one where x is equal to minus 1. Those 3 crossing points will be here at minus 1, 0, and 3. And the crossing point on the y-axis is at 0. So it's going to cross the y-axis at 0, the x-axis at 0. It's a right way up cubic, so it's going to start down here. It's going to go up above the axis, then it'll come back down, and then it's going to head up towards plus infinity again. And you'll get something that looks like that. Okay, example 5. Now this time we've got 3 repeated roots. We've got y equals x minus 1 times x minus 1 times x minus 1. And the question is, well, what does that mean? What's the significance of that on the shape of the cubic curve? I'll let you have a go at working that out yourself. Same method as before. Pause the video, come back to me when you're ready. Okay, let's have a look. Now, as I said, same method as before, so we'll find out where it crosses the y-axis first of all. So what happens if x equals 0? Now, if x equals 0, we'll get minus 1 times minus 1 times minus 1, minus 1 cubed, which is minus 1. So crossing point on the x-axis, on the y-axis rather, is at y equals minus 1. To find the crossing point on the x-axis, we say what happens if y equals 0. That means x minus 1 equals 0. And that only has one solution, which is where x equals 1. So only one crossing point on the x-axis, only one crossing point on the y-axis. So crossing point here at minus 1 on the y-axis, crossing point here at plus 1 on the x-axis. And the significance of this repeated root is that we get the special case for a cubic, where you don't get a maximum or a minimum. What you get is a point of inflection at 1. So when you get a repeated root, if you've got x minus 1 squared, then it would touch the x-axis. X minus 1 cubed, it does touch the x-axis, but in a special way. You get what's called a point of inflection. Okay, last example, example 6. They ask you to sketch this function, and it's been factorized to begin with. So we've got one factor there, x minus 2, but they haven't factorized this quadratic bit. This again is a special case, but I'll let you have a go at working out what's going on first. So pause the video again, come back to me when you're ready. Okay, let's have a look. So again, we'll just start off as before. We'll say what happens if x is 0. If x is 0, we'll get minus 2 in this bracket, 3 in that bracket. Minus 2 times by 3 gives us minus 6 for the crossing point on the y-axis. To get the crossing point on the x-axis, we say what happens if y equals 0, which means all of this will equal 0. Now, there's one solution we get straight away, which is x equals 2 in that first bracket. Any other solutions will come from this quadratic being equal to 0. So if x squared plus 2x plus 3 equals 0. Now, when we try to solve that quadratic, the first thing you should quickly do is always just check the discriminant, b squared minus 4ac. And b squared minus 4ac in this case is 2 squared is 4. Take away 4 times 1 times 3, take away 12. That gives us minus 8. Now, straight away, we can stop trying to solve that quadratic. If the discriminant is negative, that means if we use the quadratic formula, we'll be trying to find the square root of a negative number. You can't do that, which means that this quadratic has no solutions. So there are no further points where the curve crosses the x-axis. It crosses at x equals 2, but that is it. It doesn't cross anywhere else. So on the y-axis, it crosses at minus 6. On the x-axis, it crosses at 2. And it's not a point of inflection or a touching point. We've just got the one root here, x minus 2. So it will cross there. It's a right way up cubic. If we multiply the brackets, we get plus x cubed. So it's going to start down here at minus infinity. At some point, it's going to cross through minus 6. At some point, it's going to cross through 2. And then it's going to head towards plus infinity. Now, there are various possibilities for how it will actually get there in terms of maximums and minimums and that sort of thing. In the exam, it really wouldn't matter what you drew, as long as there's clearly a crossing point here at -6, a crossing point there at 2. Something like that would do. And I think that is what it actually looks like. There's a maximum here just before the -6, and there's a minimum here just after the -6. But that isn't obvious. But that is what the curve looks like. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 60 and have a go at exercise 4A. Thank you very much for listening, and cheerio.